Hey, today we're going over just the basics of vectors. A vector is essentially a, a data set. I think of it as a single column in maybe a data frame or in Excel, a single column that could be made up of numbers or characters, or for R, it can be made up of like logical statements like true or false. We'll go ahead and switch over right here. There are six types of vectors that we work with in R. The first one is called a double vector. It's also really just a numerical vector, which means that it can take the shape of any number with a precise decimal. I'll go ahead and list it right here. So as you can see, this numerical vector, it is displaying each item within the vector. The 4/7 is displayed in decimal format. The next type of vector is a character vector. Here we have a character vector that holds all the different types of letter grade that you can receive in a course, except for F or a withdrawal, or in E. Here is a logical vector. A logical vector is a vector that returns it's just made up of true and false values. And numerical vectors, logical vectors, and character vectors are, in my experience, the three most common vectors. I'm sure there's certain types of data analysis where you're using either complex or raw data really frequently, but in my experience, the three most common are character, logical, and double or numerical data vectors. They're also called atomic vectors, which means I also believe that there's non-atomic vectors. So a complex vector, I don't know much about them, but here is an example of a complex vector. Looks like there's different elements within each specific data point in the vector. And then we have a raw vector, which I would imagine is just the most raw form of any data. So here we have an example of character data being displayed in a raw format. So that gives each specific letter a value. And here's my name, Patrick. So 50 represents P, 61 A, 74 T, and so on. And that's really what makes up a character vector. Now we are moving on to arithmetic with vectors. There's a lot you can do with vectors. Right here, I'm just going to go ahead and multiply each element of the numeric vector by 2. Now you can see that it's displaying each element multiplied by 2. And this applies to all other forms of basic arithmetic. I'm going to type a statement. Numerical vector is equal to 2.2. Then it will return a logical vector, true, false, 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 false. And that matches with our numeric vector. It is true on 2.2. You can see right here, I'll do it again. Numeric vector is greater than 4. It will return a true for each element of the vector that is greater than 4, and will return a false for each element of the vector that does not match that condition. I can also use functions with vectors. Right here, I'll use the mean function, which will give me the mean of the numeric vector, or the average. I can do the same thing with the standard deviation or the variance. These are just basic descriptive statistical functions. You'll have to play around and see what else you can do with vectors. Now we're going to move on to sorting. So we can sort vectors, which will become a lot more important once we start working with data and actually doing big data projects. Numeric vectors can be sorted in increasing and decreasing order. We have it printed right here in increasing order. So it starts with the very smallest value, and then we have it printed here just in regular values so you can see the difference. And then if we change the specific argument, the decreasing argument, to equal true, then the numeric vector will be sorted in decreasing order from largest to smallest. The last thing that I'm going to talk about is recycling of vectors. I haven't noticed this very much in my regular use for my statistics classes with this R class, but recycling means that when two vectors, I'm trying to do arithmetic with two different vectors and the vector lengths are not equal, then once the smaller vector completes its cycle, it will start over. So we'll demonstrate that right here. So I'm going to create a new vector that will have a fewer number of elements than our original numeric vector. Right, so we have 3 numbers right here, and we're going to use our numeric vector. So if we add them together, we're going to notice something a little bit different. I'll go ahead and print the numeric vector to show you what I'm talking about. So we added 2 to the first one, added 4 to the second one, added 3 to the third one. Then, because that first vector was done, if you look at the fourth item, 9 plus 2 is the first item of the new vector. So we're adding by those new increments, and you can see all of them right there. And that's what recycling within vectors means. And that concludes this video. Thanks for enduring my first tutorial video with me.